Hello everyone. In this tutorial I would like to show you how to do scatter plot, correlation analysis, and simple linear regression and multiple linear regression using SPSS. This data file is for demonstration purpose only, and my purpose is to show you how you can use SPSS using your own data set and run these methods. Many times you will have a quantitative variables in your data set, and you want to see if these two quantitative variables or these two numerical variables have relationship or not. And generally one of the way to establish relationship is to doing a scatter plot, and quite often you also want to show the strength of the relationship, how strong the relationship is. So correlation analysis is quite commonly used, and then linear regression is to find out what's the impact of your independent variable has on dependent variable. So regression is quite common. Linear regression is quite commonly used techniques in statistics. So I want to show you these things. So this is a data set. This data is related to COVID, and prepared by some students in my class, and I want to show you how we can do, first of all, the scatter plot. So first of all, like any analysis, you need to think about it, what you want to analyze, and basically you need to have some sort of a analysis plan. In other words, if you just right away dig into your analysis without giving any thought, then it will be very difficult to really come to some good analysis. So therefore it's good to have some sort of a plan in terms of what variable you're going to analyze and what you hope to establish. So it's good to have some planning. So in this data set, this is a COVID-19 related data, and one of the variables this data set has, which I think would be interesting to show, would be so they have quite a few good variable data. So one of the variables this data set is a COVID related deaths, okay, and a number of COVID cases. So let's say if I'm interested to see what type of relationship do I see between the COVID related death and the number of COVID cases. Okay, so I'm just going to show you how to establish these two relationships with scatter plot. So what you do is a scatter plot. When you do using SPSS, go on the graph, chart builder, click on the chart builder, okay, and this something will show up. So I will just say okay, and then you see this menu showing up. So it has quite a few options of chart. So in this particular one, I'm interested in the scatter plot. So check on the scatter plot, and it's very obvious. It's asking you what do you want to what do you want in X variable, what do you want in your Y variable. Generally, as you can see that X typically means your independent variable and Y is really dependent variable. So in this case, I'm going to scroll down, and the variable I'm interested is in its COVID related death and number of COVID cases. So if you want to see a variable, if you right click, you see the variable name. Right now label is appearing, so I can click the variable name and you can see that. So you can kind of play around between by clicking the mouse, right click, then you will see this option. So again, if you right click your mouse, you see this option. So you can, if in case sometimes it's very hard to read the variable name if you have the whole label showing up, so you can always right click and look for the variable name. So you can see the variable name is showing up here. So I'm just going to select the number of cases as on the x-axis and the death on the y-axis. Okay, now generally, I mean, again, when you're plotting this diagram, you probably have some expectations in terms of what do you expect, right? What our expectations are. So you can always have some expectations. So my expectation here is I should see a positive relationship. In other words, as the cases are rising and death is also rising, for example. Okay, so we'll see. I'll see if that's true or not. So I'm just going to say okay. All right. Once you choose. So don't worry about the other set color, set size, filter. Sometime you can ask for some colors. So in this case, I'm not worried about some colors or size, something like that, or filter. So I'm just going to say okay. So right now, what I'm seeing right now is this scatter plot showing up, and you see this scatter plot. You definitely see there is a positive relationship happening, and obviously there is just some you can see there is a two data points showing up and the extreme high number of cases and the death, right? So you can see that these two cases, extreme cases, they have a very high number of COVID cases, and they also have a very high number of death as well. Now, so it's definitely showing that there is a pattern. You can see there is a large number of cases where the number of cases are not as high as these two countries, for example, right? In case if you say, you know what, perhaps this might be a extreme cases, can we just remove these two cases for the purpose of illustration and see what relationship do we see here? For example, answer is yes. You can always change your label and just to focus on these dots here, these points on this left hand side here. So of course you can right click this scatter plot, and you can always change your axis. For example, if I'm interested in changing for the axis, so I can simply right click the x-axis and change the scale. So right now it's showing up maximum is 800. Well, how much is a big number? It's 8 million cases. Wow. And then we have an increment of 2 million. So if I just wanted to show, for example, just up to 2 million, so I can say maximum is 2 million and minimum is 0, for example. Okay, so minimum. So you just change the one setup. You can show, if you want to show an increment, for example, if you want to show increment of, I don't know, let's say 1,000 each or something like that, for example, something like this. You can apply, change it. So it's asking for maximum is, so I'm going to go back again and change to the scale again. So it doesn't accept my scale, so I'm going to the maximum is 2 million, for example. So just change the scale here, and yeah, so you can see that it's changed here a little bit. So major increment automatically changed to 500,000. 2 million is maximum. So you can see that this is again, if you want to change this one, if you want to really see a because right now the axis scale is very large, so sometimes it may not see a good pattern, but you definitely can make from this plot that there is a positive relationship. But if you want to see a slightly bigger impact, so right now I'm just going to change to this number to 100,000, for example, and now it's slightly much better than the when you started, for example. You definitely can see that this is a positive relationship. As the cumulative cases are going up, the number of deaths is also going up. So what we did was we did not delete anything per se. We just removed those two data, which was extreme values, from the plot, because most cases are here, as you can see that. So this is your scatter plot, and it's definitely showing as a strong positive relationship happening, for example. Of course, there is quite few countries. You can see that the big blobs here is showing up there. they have this cases, but they also look like death is number of death is also seems to be under control here cases, but for most part there is a strong positive correlation, looks like. Okay, and again, as I said, I don't want to read too much into this data because we don't know much details about this data, how this data was collected, the time frame of this data, so there is a lot of questions we don't know about this data. So the purpose of this exercise is to just to show you how you can do it. Now if you see that there is a strong correlation and you want to know exactly what's the correlation coefficient is, so you can do a correlation coefficient here. So next thing I'm showing you is how to do a correlation analysis. So of course we have these two variables, so we want to establish a correlation coefficient. So we're going to analyze, and then we're going to use a correlation, and we select on the bivariate. Okay, and I'm interested in these two variables, right? So I'm just going to select those two cases here, this death and the cumulative cases, these two variables. And the good thing about in SPSS, you can select as many as variable you want, and you can have a nice correlation matrix actually. But for the purpose of what we're just doing it, I'm just choosing a two variables. Generally, bivariate, as the name implies, bivariate correlation is looking at the two variable two variables. So I'm just going to show you two variable correlation coefficient. But if you have more than two variables, you can click them here. It will give you a matrix. I'm going to show you that one in a second, but for now I'm just going to show you these two correlation coefficient, and we keep the Pearson because these two variables are quantitative. Okay, Pearson is fine. Is asking what test of significance they want, two tail or one tail. So two tail mean that there is a correlation. One tail, generally we do it when we try to say if there is a one direction. I leave it two tail. I think two tail is more conservative, and if there is a correlation significant, by looking at the correlation coefficient, you can easily say that one correlation value is that whether the relationship is a negative or positive. So that's a one direction test. So I'm pretty much going to leave the thing as it is. There's a bunch of other options there are. For example, you can look for this mean values. For example, it also asking you a covariance also. You can if you're interested in, you can look for some statistics. So we can leave the statistics also. We can say okay, mean and standard deviation statistics sounds good. There's a few things as well, like for example styles, etc. I don't really use this feature, so you can just leave the side. The bootstrap is also quite interesting. Sometimes because of the sample size we have less, so sometimes you could use bootstraps. It makes your coefficients more stronger. Just say, oh, what if we have 1,000? So what we does is it randomly select people cases you have 1,000 samples, for example. But for now I'm not going to use the bootstrap, so I'm just going to leave them as it is. I'm just going to select these two variables, and in option I only check these two options. So for now you can leave these two, style and bootstrap, as it is, and I'm just going to run my correlation. Let's see what will happen. Alright, so this is a correlation coefficient. Okay, and you can see that from the output the average death for the COVID is 8,000. Cumulative case average cases is 294,000. all right, on average for countries. And just keep that in mind. And total number of sample size we have is 71, and these are the standard deviation of those two variables. Just keep that in mind. Is as I was explaining the chart, the mean could be influenced by the outliers, so extreme values. So if you think that those two countries I just have in my data set, which has a very high strong death rate, for example, because most places doesn't have this 8,000 death, for example. So you can remove those two cases from the analysis. So in other words, it's not necessarily removing them, you're just excluding them. Okay, the case still exists there, for example. Okay, but I'm not removing at this point, because at this point my goal is to show you how to run analysis and how to interpret the result. So that's what I'm trying to do is here. But it's some of these values, for example, if you think that there is some extreme numbers I showed you, so you can exclude them from analysis. So I'm just going to quickly show you how you do that, for example, right? So you see that in this is the data view. What you see is data view, and this is variable view. In the variable view, you will see these are the variables. The first column contain your variables. Okay, the first variable is the name of the variables you have, and these are the two cases I'm interested in. And if you see that there is a column called missing, so if you click here on the missing, and you can write down exact what you want to show as a missing. So let's say if you already know this is 80,000, so you just write down your 80,000, for example, right? As like 80,000 was extreme death, for example, right? So you can literally can write down, let's say, I don't want to include 80,000, and when you do the analysis, it doesn't really delete it, which I like about it. It just removes it from the analysis. The same thing for cumulative cases. We know that most cases are not in hundreds of thousands, but if you want to remove the specific case, in this case we have is a country, so you can definitely write down that any number, the specific number, and then you say I want to remove this. So this is how you do it. In case if you want to remove any outlier extreme numbers, you can come to your variable view, select that particular variable, and write down exact value you want not to be included in your analysis. Okay, so. And one more thing you notice is, since I'm in the variable view, when I use these two variables, the both are scale variables. Okay, they both are quantitative variables. They are not nominal variables, but scale variables. Okay. All right. So let's go back to my analysis here. So this is a correlation coefficient here. So this is your small matrix. So you see that there's correlation between the death and the cumulative cases is 0.941. So this is showing as a very strong correlation and positive correlation, right? Because this correlation coefficient 0.941 doesn't have a negative sign, so this is positive. And correlation coefficient varies between -1 to +1. So 0.941 is a positive number and is close to 1. So this indicates it's a very, very strong positive correlation coefficient. So as indicates that as the cases are rising, so the death is also rising, right? And next thing is, I think which is very useful, is your sig value. This is p value you have here, 0.00. So as you can see that this value is way less than 0.05. So 0.05 is your alpha value, the significance level. And in this example, this sig value, which is basically called p value, is way less than 0.05, your alpha value. So therefore correlation coefficient, its significance. And this n is 71, and 71 is the number of cases in this case, or the sample size. Okay, number of cases in this particular data set refers to countries. Okay, and you also notice that there are similar type of number in across the diagonal, so you can ignore one number because they are identical numbers. Okay, so this is how you do your correlation coefficient. And as I said, if you want to run more variables in your correlation, you say, you know what, I want to put, I don't know, let's say GDP also, for example. I want to put something else. Let's say I want to put, for example, unemployment, for example, right? So yeah, you can do that too. You can simply say okay, and then you have a bigger matrix number. So you can definitely have this bigger table. You can see that now you have this bigger table here, right? And these are the correlation coefficient. You same correlation coefficient between that and the cumulative cases, 0.941 positive. And seems to be there is also a positive relationship with GDP of the country and the death, and it seems to be also, but of course these two are very strong correlations, positive strong correlation. And then we have this unemployment in the death rate. So it's not very strong, it's 0.27, but it's still significant at 5% level. 0.023 is your p-value. Okay, So this is how you do your correlation, and this is how you do your scatter plot. And yeah, so give yourself a try, and see if you can do these things using SPSS, scatter plot, and correlation coefficient. The next thing I want to show you is a regression. So for example, you say you decided that you would like to do a regression, and what would you do? So again, as I said, it's always a good idea to have some planning before you do run regression, because if you try doing analysis kind of on a fly without any thought, then I would not suggest that will be a good idea. So for example, one thing I'm interested in this data set is the recovery rate. So recovery rate is one of the dependent variables in this case. So does the recovery rates depends upon the GDP, for example. So we have this GDP. So we have this GDP last, and unemployment, for example. So unemployment. So we have unemployment variable also. Here is the unemployment. Unemployment rate. Sorry, unemployment right now is recent, and this is the last one, for example. So we will look into this case, and again, as I said, I'm not really spending too much time to explain these variables, because the author of the data probably have more idea about these variables, because they are the one who collected this data. So as anyone who would collect data, they'll probably do slightly more investigation. They probably have better perspective. This particular data set is a secondary data. This data was collected from other sources, but you could have a survey data, for example. You could have collected data through your survey. So and then in that case, you probably have better understanding. And again, if you collected data using secondary sources, you probably have better understanding. You probably explain this variable better. So which I don't have this background, because I am using this data file as an illustration. So so therefore, I'm not reading too much into these variables. But what I'm trying to say is, if you are using this data set of your data set, so make sure that you have a good understanding of your own variables. You need to have good understanding what variables do you have, and what they mean, and why you're using them, and again, every analysis must have an overall objective. What is your objective is? Because normally anytime when you select your data, you have certain goals in mind. You want to establish something, you want to create some hypothesis, you want to prove certain things. So make sure that any analysis you do, it's revolve around your analysis goals. Okay, so therefore try to have more organization in your analysis. So if you want to do your regression, you click on the analyze. So this is the very important menu. It has pretty much most of the analysis you're going to do. So I'm going to select here regression. Okay, and I'm going to select linear regression. Here, this is a linear regression. I selected them, and here is this dialog box shows up. One good thing about using SPSS, a lot of this options are menu driven, so it's very easy. You just click and drop, and it does it for you, all the analysis. Okay, so it's not very difficult. It's a relatively easy program to learn and do it. Okay, of course, if you're using it first time, you have to watch this video a few times until you see what steps I'm taking. And the good thing of having a video, you can always pause and reflect and do it your own data analysis. So let's say, as I said, I'm interested in the recovery rate. So again, I want to see my variable view. I click here, and I have this my recovery rate. And let's say if recovery rate is my dependent variable, and one variable I'm interested is in, let's say, GDP per capita, for example. Let's say so this particular data set has 3 GDPs. Okay, so I'm just, for illustration purposes, I'm going to pick up one, right, this as an independent variable. Okay, and just to show you how I'm doing my simple linear regression. So when you do a simple linear regression has a one dependent and one independent. Okay, so that's what you do. This is how you do it when you do your linear regression. There's a few other options like statistics. It's asking you what you want to see. There are a few interesting things happening, and of course you can look at the collinear diagnostics, for example. For now I'm just going to run without all this option, but I'm going to show all this option later on. So I'm just going to leave the default because it's a simple linear regression. It also has a plot, which is also pretty cool, especially if you're looking for normality plots. You can always look for normality plot, for example histograms. I'm going to run them in a second time when I'm doing multiple regression. I'm just going to leave them as it is. Okay. You can also save your output. This is also very interesting because you can save your predicted values, which is your y hat. For example, these are residuals. You can save them if you want to use further for your residual analysis test. So it has a few things. Have a look at it. And this is the option. And within the option, there's a few things showing up right now. The f probability of f. So it's using alpha 0.05, removal 0.1. Because if you see a regression, it uses ANOVA table, if you remember the theory of regression, right? So I'm just going to leave them as things as they are right now. Okay, so I'm just going to run here, and you see that this is showing a model summary. This is your R square. This is R is a correlation coefficient. It's showing you that the correlation between the GDP of the country and the recovery rate, your dependent variable. The independent variable is also known as a predictor, is 0.015. So it's showing you that there is a correlation. R is 0.122, which is positive, but it's not very strong. Okay, so it's saying that recovery rate is not strongly related to the GDP of the country, for example, and the R square is 0.015. R square is basically saying 1.5% of the variation in the recovery rate depends upon the GDP per capita of the country. So this is not a very strong R square. So in other words, this is not a very strong variable. Okay, but still defining nevertheless. And look at this is ANOVA table. All right, this is the one number I'm interested is in this R. This significance value, which is 0.313. Again, this is not very strong number, for example, and you can see that similarly the GDP per capita is also showing up not significant. So this is okay. In one word, this is your simple linear regression. Okay, this is simple linear regression result, and so next question is it significant? Answer is not significant. You can see that the p-value for the t-test, okay, on this coefficient table here, 0.313. So this is not significant. This is a slope. It's also very, very small slope. So so therefore, if you want to use this regression in your analysis, you flip. Of course, you can use them, but is it useful? Answer is no. It's not very useful. So this is the simple linear regression. So what I want to do is I want to go back to our original example where we're looking at the death rate and cumulative cases and just see simple linear regression, what that look like. So I'm just going to go and analyze. Again, I'm going to do a simple linear regression. Okay, you can always reset so that you have a nice clean menu here. So again, I'm just going to select my let's say death rate as my dependent variable, cumulative independent variable, and I'm just going to run this one. So you can see that right now, and if you remember when we did originally our value, the correlation coefficient was 0.941, and we see the same correlation coefficient, and you can see that the R square is 0.886, which is 88.6% of the variation in the death rate is explained by the variation in the cumulative cases. So it's a very strong correlation coefficient. And again, if you see the ANOVA, the p-value for the f-test, which is also less than 0.05, so still very, very significant. Okay, and this is a coefficient. So constant 1282 is your b0, the constant, the b0, the y-intercept, also known as, and this number 0.023 is a slope. Okay, this is a slope. So so normally slope is saying that if the cumulative case increased by 0.0 if it by one case, for example, then the death it goes up by 0.023. So that's what it means by. So if you do a unit change of x variable, what's the average change on the y variable? That's what it means here. So with every one case increase, that it goes by 0.023 case. Okay, so that's interesting, and again this is significant, right? So so this is your one way, and again I don't really enter when I do a multiple linear regression. I don't really try to stuff as many variables possible. I need to have some sort of a background understanding. So therefore, when you do multiple linear regression, again give a good thoughts of what variable you want to try and use them. So let's see if I'm using the same example of dependent variable as a death and cumulative as an independent variable, and can we try some other variable as another independent variable, because when you do a multiple linear regression you tend to have a multiple independent variables. So for now I'm just going to choose the employment rate, for example. Maybe I can choose this employment rate, for example, unemployment rate, right? So this is the after the COVID, right? And as a new employment rate. So what we right now have is a multiple linear regression we are doing right now, because we have two independent variables and one dependent variables. Okay, so of course we can't have more than one dependent variables unless you try different next model. But in this model, death rate is number of death is a dependent variable, cumulative cases and employment rate is a independent variable. All right, so actually this is a rate, so I'm just going to get the latest unemployment, right? Because latest employment rate I'm using them, not the change. Okay, so let's take these two numbers, and again, as I said, I'm not reading too much into these variables at this point, because of my purpose to show you how you would use SPSS. Okay, so that's what this is how you do it. I want to quickly go over some of the stats I was talking about. So I said I don't want to there's a few interesting things happening. This is the Durbin-Watson test statistics. It's kind of show you if we have a problem with our residuals or not. Like in case it will show you some outlier values. I will also look for the collinearity diagnostics. Okay, and what else it has? You can look for descriptive stats as well. Okay, it's you can even look for some case-wise diagnostics also, in case if there's an outliers, and we already know that there are some outliers when I was doing a scatter plot, so we can do this thing as well, and continue, and definitely want to have this a normal probability plot histogram. So if you want to do a residual plot, you can use the standardized residual plot, so it does it for us, which is kind of nice. You don't want to save anything at this point, but if you want to save your outputs, like especially predicted value with your y hat, you can do this option. And also if you want to show a Cook's test for the residual analysis, so you can save those words Cook test for the values. But I'm not saving anything, because before you save anything you need to have very clear perspective, because anytime when you click here, it saves on a data file. Then you'll end up having a very big data set, and if you're not really sure why you're saving them, then it's not a very good idea, because then you have lots of variable attaching to your existing data set. So I'm not saving at this point. Normally when I save, I have a very good idea what I want to do with this save variable, so I'm not saving at this point, so I'm just going to cancel this thing. In the option, again, I'm leaving things as they are, right? I just want to briefly talk about this list-wise and the pair-wise. So list-wise will exclude any cases which are missing. So if you think your data set is complete, then list wise is a good case. But if you think that there is a lot of missing values, then those missing values will remove those cases. So it might have impact on your sample size, because sample size become even much smaller if you have missing cases. And pairwise is allows to use pair at a time, so it's better than list-wise, right? And if you have cases which are missing values, then it synthetically replaces them with mean values, right? But for now, I'm using a list-wise. For in this particular data set, there's not too many missing values. I think this data set has a pretty full data values, so not too many missing values. So I'm just going to leave this as a list-wise. And that's pretty much it. No bootstraps. We're not doing any style change either, so we just leave them as it is, and then we're going to say okay. So what we're really seeing is right now is a descriptive stats, and again these are some of the mean value for those variables you have, and some of the mean values you already know that. So in this latest unemployment rate is 9.6% unemployment rate, and the standard deviation is 0.0769. So this is seems like there's a huge standard deviation given the mean is 9.6. And one of the problem with the small data set in extreme values, it definitely can have a huge influence on the results. And these are the correlation. So you can see that there's a correlation, strong correlation between the death and the cumulative cases, 0.941, and it is significant. But you can see the unemployment and the death, the correlation 0.082. So 0.082 is a positive number, but it's very it's insignificant. The statistically is not significant. You can look at the p-value is 0.247, so it's not very significant. Okay, and so if you see this result here, so it's showing you that it's r square is 0.943. So r is a multiple correlation coefficient because it has a multiple independent variables, right? That you see this independent variable predictor, so it's using unemployment rate as well as the cumulative cases, and the r square is 0.8888, so 88.8% r square. That's what it mean by that then because of this unemployment rate and the cumulative cases, it explains 88.8% of the death. And but if you see yourself here, and mostly it is because of the cumulative cases, not because of the unemployment rate. This is significant as we expected, right? We saw even before that the cumulative cases are significant, so this is significant. What is interesting in my opinion is this coefficient table right now here. So this coefficient table, again, from this coefficient table you get your intercept B0, you get B1 for the cumulative cases, and B2 you get for the latest unemployment. So these are your slopes. So we know this 0.023, we are familiar with the 0.023. This is slope, and this slope is significant. Look at the p-value 0.000. So this is p-value is way less than 5%, but look at this latest unemployment. So this is not significant here, so it's not significant at all, for example, right? So it's seeing that this variable is not significant in the model. I'm a little bit concerned about the negative sign. This negative sign should not be there, even though this is not significant variable. The reason I'm concerned because when you look at the correlation coefficient here, this correlation coefficient is now negative. You see what I mean? We call them face value, right? Or face validity. Face validity is the right term, face validity. So this is showing up as a positive number correlation, but on the slope is showing up as a negative number. So it's definitely seems to be some problem with this variable. So if I rerun this analysis, I will definitely remove this variable in the model because this model is not stable. Okay, and there's a bunch of things happening here. This is a collinearity diagnostics here, okay, and this is a residual analysis here, okay, and this is very interesting. So remember, what I like about this case-wise diagnostic is it will show you the variable which has a outliers. You can see that there are three countries, 32, 47, 70, the case number. And again, how do you look for those cases? For example, if you go, go back to data set, and there is a case number 70, for example. So the case number 70 is United States here, showing up case number 70 is United States, for example. And what else they have in this output, so we can always go back. And there's case number 47. What is case number 47 is? Case number 47 is Mexico, and there's one more case showing up as an outlier, and which one is 32. So no, extreme number. So 32 is, what is 32? 32 is India. So these three countries showing up, India, Mexico, and USA, showing up as an extreme number. So you can see that is their COVID death is way higher, is showing you right now, than most other countries. And this is what they predicted, but this is they're showing up. So you definitely see that there is a huge residuals relatively. So it's so of course I like this case by diagnostic. You can see that that there is a 3 countries, perhaps they are skewing the result because the number seems to be in extreme ends. So again, normally you can reflect on this issue. You said for the next analysis, should we leave them here as it is, and talk about them as a special case in the analysis, or you remove, or you, as I said, you treat them as missing values and run the model without these 3 cases and talk about them as well. But in any case, whatever you do, make sure you do talk about these cases as well, because this is very interesting. Now this sort of problem normally happens when you're doing some actual data like this, like some sort of secondary data, right? But if you're using a survey, mostly survey doesn't have this type of problem, because surveys generally you give them a scale, like say 1 to 7 scale, and then the probability of something like this is very rare. Okay, so this is interesting. This is your residual analysis. It's showing you the residual. What I want to show you very quickly is any residuals, the average of the residuals is 0, and you know that if you take all the residuals, what is residual is y hat. So y hat is your predicted value. If you subtract predicted value from the random values, that is y minus y hat, that is your residual. If you take all the residuals and you take the average value, this is always equal to 0. Okay, so that's what residual is, and kind of showing you what does residual look like, residual values. Okay, and this is your scattered, this is your residual plot, and you can see that is, so there is a few cases. You can see that is in the residual plot, there are few cases that are showing up to the either very extreme values, and we saw that there's a for one country the value was in the negative residuals, and some positive, some 2 countries. So we definitely see that those numbers are showing up on the extreme side. So but in terms of the plot, it does look like a normally distributed plot. The residual does look like a non-normally distributed. Okay, and this is also very interesting. Okay, so this is also a so normally when you do this plot, normal probability plot here, draw them. So these are these dots, you see that, right? So this dots kind of indicating that is the expectation is this dot should be close to the line, so that we can establish that relationship is a normal. But we do see that there is a shift in the dots. It look like there is some curves happening. So that really indicative of extreme values, and we saw them here as well. Like some cases is over predicting, some cases under predicting. So there seems to be the case from this plot we can notice. Okay, so that is how you do your regression. I will talk about some of the details of interpretation and some of the statistics in the class. But as I said, the goal for this exercise is to run your scatter plot. Okay, that's what the first thing I did. I ran the scatter plot, and second thing I did was to show you how to do your regression, linear regression, right? You can do first time with one variable. It's a simple linear regression. You can add more variables, As a matter of fact, you can eat even more variables, for example, something like this, for example. So you can have a multiple models. So this is called multiple linear regression. Okay, and yeah, that's pretty much is how you can use SPSS to run these three things. All right, so give yourself a practice and try if you can able to practice these three things in SPSS.